Welcome back to College Algebra. In this lecture video, let's take a look at how we can graph the quadratic and absolute value functions. So the reason why I want to graph the absolute value functions because absolute value functions holds a lot of the same characteristics as the quadratic. So we will do that as a last problem here. All right, so let us use everything we learned so far to graph our quadratic function and absolute value function. So the first thing I got to do is find the vertex. So let me just write it up here real quick. So a times x minus h whole thing squared plus k. So right now my quadratic function is written in general form. So the x match, the subtraction match, so h got to be 4. And my k got to be -9. So my vertex is going to be located at 4, -9. All right, let's find the x-intercept. I'm going to do it down here a little bit. So my function is x minus 4 whole thing squared minus 9. All right, to find x-intercept means find x when y equal to 0. So I'm going to set my f of x, which is representing y, equal to 0. So that will be 0 equal to x minus 4 whole thing squared minus 9. So since I only got 2 terms here, so I'm going to move my -9 over to the other side. And that will give me x minus 4 whole thing squared equal to 9. So to get rid of the squares here, I will take a square root on both sides. So whenever I take a square root on both sides, my answer is always going to be positive and -3. So to get x by itself, let's move over the -4 to the other side. So my x is equal to 4 plus 3 and 4 minus 3. So 4 plus 3 will be 7. And 4 minus 3 will be 1. So I got 2 x-intercepts. All right, in order to find the y-intercept, that means find y. Let me put my graph down. Y-intercept means find y when x equal to 0. So I can say this is going to be 0 minus 4 whole thing squared minus 9, which is -4 squared, which is positive 16 minus 9, which will give me 7. All right, so my y-intercept is at 0, 7. The axis symmetry is the vertical line that will cut through my parabola. So the only point that the axis symmetry touches is the vertex. So since it's going to be a vertical line for the axis symmetry, so we will actually type in as x, or we will write it as x equal to 4. So once it hit the vertex, the equation of the vertical line is always equal to a number, and that number got to be the same number as the x value of the vertex. All right, choose the x value. There are 2 placed to the right and 2 placed to the left, okay, of the symmetry. So let's think about this here for a minute, okay? Vertex is 4. The x value is 4. So if I want to pick 2 placed to the right, which is 6, and 2 placed to the left, which is 2. So in that case, if these are the x value I'm picking, then I would need to find the y value. All right, so let's plug in 2 right here. So if I plug in 2, there'll be 2 minus 4 whole thing squared minus 9, which will give me -2 squared, which is positive 4 minus 9, which will be -5. Same thing for if I will pick 2 placed to the right of my vertex, x equal to 4, that would be 6 minus 4 squared minus 9. 6 minus 4 is 2. 2 squared is 4. 4 minus 9, again, is going to be -5. So this is the way how we actually shows that parabola is an even function, okay, because the 2 y values are exactly the same. All right, so I got 2 other points, so I'm going to say 2, -5 is my answer, and the other points that I will use is 6, -5. So use the vertex, x-intercept, y-intercept, and the 2 point I just found to graph. So 4, -9 to the right, 4 down 9. That'll be right here. The bottom of my parabola is down here. X-intercept 1, 0, 7, 0. All right, 2, -5 is right here. And 6, -5 is right here. So now I can actually draw my parabola. Oh, forgot the y-intercept. 0, 7. So let's give me a little bit more accurate picture. All right, we get an idea. It's a U. I didn't turn very well. All right, find the domain. The domain for quadratic function or parabola is always the same, from -infinity to infinity. All right, the range, gotta be careful with the range, okay? The very bottom of my parabola is the vertex. So the y value of the vertex is where I'm gonna start. So it's from down and up. So that should be -9. Keep on going up to infinity. All right, let's try another one. So this one is written in the ax squared plus bx plus c form. So we got to in order to find the vertex, we got to extract our a and b. So let me put it right here. So f of x equal to -x squared plus 4x plus 5. So my a is -1, my b is 4. So for the vertex, the h, which is -b over 2a, so that will be -4 over 2 times -1, which will give me +2. All right, so now I plug it back into my function to find the vertex. So that'll be to find the y value of the vertex, that'll be -2 squared plus 4 times 2 plus 5. So I'm just going to punch this in the calculator real quick. That'll be negative parenthesis 2 squared plus 4 times 2 and plus 5. All right, my y value will be +9. So that will be 2, 9. That will be my vertex. All right, x-intercept, find x when y equal to 0. So let me do it right here. So I'm going to set my function equal to 0. All right, so let's try to solve this by factoring. I'm going to move all three of these terms to the left side so I can keep my negative x, my leading term or my leading coefficient as positive x squared minus 4x minus 5. All right, let's do this by factoring. I think this problem is factorable. Since the last sign is negative, the choice for the sign is 1 positive, 1 negative. So to end up with a -4 in the middle, I need -5 on the outer, +1 in the inner. So when I set each one of these factors equal to 0, my answer should be -1 and +5. So my two x-intercept, -1, 0 and +5, 0. All right, to find the y-intercept is pretty simple. Just imagine if you substitute 0 for all the x you see, then the only term that's left, the only answer left is going to be +5. So my y-intercept is going to be 5, 0. 0, 5, excuse me. Write them as coordinate form. All right, the axis symmetry is the vertical line that's going to cross over cut my parabola in 2 halves. So that vertical line got to have an equation x equal to 2. All right, so let's pick the 2 points again. All right, so 2 is my vertex. So I need to go 2 places to the right, which is 4. 2 places to the left is 0. So earlier when the y-intercept was 0, the y value was 5. So we're taking care of that. So 2 places to the right, imagine if I will put 4 in, substitute 4 for x. So that will be f of -4. That would be -4 squared plus 4 times 4 plus 5. Okay, 4 squared is 16. 16 times -1 is -16. Positive 4 times 4 is +16 plus 5. So the 216 cancels out. My y value again is 5. So that's the reason why I kind of already know ahead of time this y value will be 5 as well, since I know my parabola is actually even function. So these two y value got to be the same. All right, 0, 5, 4, 0. So the 2 points, 0, 5, and 4, 0. Okay, let's graph 2, 9. To the right 2, up 9. This up here. -1 and 5, 0 is right here. Y-intercept was 0, 5. And the other point I found was 4, 5. So by looking at this function, since my leading coefficient originally was negative, I know my parabola got to point downward. So now that makes sense. When I draw it, it got to point downward. There you go. So that's how we sketch it using some of the points we already found. All right, domain for vertical parabola is always the same, which is always from negative infinity to infinity. All right, range. Remember now, range is down and up. So the highest point it reaches for the range got to be 9. So my range got to be from negative infinity all the way up to 9 using brackets. All right, let's try one with the absolute value. Okay, very similar as the form that is a times x minus h whole thing squared plus k. Except I'm not having square here. I'm having absolute value instead of the parenthesis and the square. So by looking at this absolute value function, it has a general form of a times x minus h, okay, plus k. All right, very tricky right here. Normally, it's supposed to be x minus h. Right now, inside the absolute value is 2x minus 4. So what we can do is to think about it as factoring out the 2. If I factor out the 2, that would be x minus 2. Okay, so if I will rewrite my 2 term inside the absolute value, that will be negative absolute value of 2 times x minus 2. Okay, minus 3. So the h is actually going to be the 2. The k is still going to be negative 3. Okay, so my vertex is going to be 2 comma negative 3. All right, so the work, so a lot of times when students find the vertex here, I will be looking for, okay, the work like this to know that you can look at it. You can actually look at the equation and know the vertex is 2 and negative 3. Rather than graphing it on the graphing calculator, okay, I got to see something like this. Okay, it shows me that you know to actually trying to match the 2x minus 4 into like a x minus h form. Okay, we'll talk a little bit more about this 2 right here we factor out in the other video. All right, let's find some x-intercept. I'm going to write my problem down here again. So as you can recall, if you ever took our math 108 class, we talk about how to solve the absolute value equation. So find x when y equal to 0. So that'll be negative 2x minus 4 minus 3. All right, I'm going to move my negative 3 over. Excuse me, the other way. Move my absolute value term over since it's a negative absolute value. So I want to isolate my absolute value term first. Okay. Oh, my bad. This is not negative 3. It's supposed to be plus 3 right here. Let's change that to a plus 3. If I change that to a plus 3, my vertex will also change to 2 comma 3. That was my fault. There's a typo on the handout. All right. So change the negative 3 to a positive 3. Equal to positive 3. All right, once the absolute value is by itself, then we will set what's inside the absolute value equal to a positive 3 and set what's inside and tell what's inside the absolute value set equal to a negative 3. And then we can solve the 2 equations simultaneously. So that would be 2x equal to 7. The other one is 2x equal to about positive 1. So when I divide both sides by 2, that will be x equal to 7 over 2 and x equal to 1/2. All right, so my x-intercept, 7 over 2 comma 0 and 1 over 2 comma 0. So 7 over 2 is about 3.5. I need to know that so it can actually help me. Plot on the graph here. So, but if you ever done a problem like these for quizzes or knowledge checks, I'm expecting you to see. I'm expected to see the exact answer. Okay. Let me go ahead and plot them. 2, 3 to the right, 2 up 3. 1, 2, 3. 0.23. About 0.5. That's about here, and about 3.5. 3.5 is about 1, 2, 3, between 3 and 4. All right, my y-intercept. Let's find the y-intercept real quick. So find y when x equal to 0. So that will be negative absolute value of 2 times 0 minus 4 plus 3. 2 times 0 is 0. 0 minus 4 is negative 4. Absolute value of negative 4 should be positive 4. But since I still have a negative 1 times outside the absolute value, then my 4 will still become negative 4 plus 3, which is going to be negative 1. So my y-intercept is going to be 0, comma, negative 1. That'll be right here. All right, let's find the 2 points. Okay, absolute value is also an even function. Okay. So, the axis symmetry is same thing as the parabola, x equal to 2. All right, let's find the other two. Let's find another 2x value. There's 2 placed to the right and left. So my vertex is going to be located at 2, 3. So 2 placed to the right is 4. 2 placed to the left is 0. So I already found the y-intercept was 0, negative 1. That would be this point is plotted. So when the when we pick x equal to 4, substitute 4 into the function, that'll be 2 times 4 minus 4 plus 3. So that's 8 minus 4, which is a 4. Absolute value of positive 4 is still 4 with a negative 1 times in the front. It's still going to become negative 4 plus 3, which is negative 1 still. Okay, that's how we show that this is an this is how we show that this absolute value function is still a even function. So that's 4, negative 1. Okay, just like the parabola, this a, okay, is negative. So that tells me my v, my v shape is actually going to point downward. All right, there you go. All right, domain of my absolute value function is always the same from negative infinity to infinity. Range down and up, so it must be coming down from negative infinity, reaching our y value of the vertex. That's the highest point, which is 3. Okay, so as you can see, there's a lot of similarity. There's a lot of similarity between quadratic and parabola. That's why I want to go ahead and show you how to graph an absolute value function, okay, using the similar characteristics of a quadratic function. All right, that will conclude this lecture video. Thank you for watching.